Welcome back. Let's continue what we started. Now, here we are going to look at variation of at rest earth pressure. Now, we looked at the three key conditions. We said we have the at rest earth pressure coefficient, we have the active earth pressure coefficient, and the passive earth pressure coefficient. And I explained to you conditions for each of them. Now, for at rest, we said that the retaining wall, this is the retaining wall that we have here, that is retaining this soil mass. So this is our soil mass. A retaining wall that is retaining the soil mass. If it is at rest, then we see that the soil mass is in static equilibrium. You get it? And so the lateral stresses that is going to act on the retaining wall, we'll call them at rest earth pressure or at rest lateral forces. Do you get it? And the K that we are going to talk about in this condition is going to be K naught. That is what the at rest earth pressure coefficient. Now it varies with depth. Do you get it? So the at rest pressure here will be different from the at rest pressure at this side of the retaining wall and to be different at this side and at this side. And so that is what we are going to look at. Now, there are some conditions that we need to take into consideration. Now, here, one, we are saying that the soil mass is homogeneous. So, soil is homogeneous. Then, here we are saying that there is no water table. So, we are looking at the dry soil, no water table. Then, three, we are saying that the distribution of the at rest, the distribution of the at rest lateral earth pressure for dry soil is what I have shown in this diagram. So this is the ground surface. This is the ground surface. This is the ground surface. This rather is the ground surface. This is the retaining wall. Now we want to look at the distribution. You get it? So let me put a schematic diagram here and let's see the distribution. Let's see the distribution. Now let's see this is our depth Z. So let's see, let me write here at Z equal to 1, which is 0. At Z1 equal to 0, then we know that our geostatic stress will also be, which is gamma Z, will be what? 0. And if it is 0, we know that our lateral stress will also be K naught gamma Z, right? Which will also be 0. So at the ground surface, our at rest earth pressure will be 0. Now let's assume that the distance from here to here is what? Is h. Then let's look at the bottom. Do you get it? So at z2 equal to h, that is at the base of what? Of the retaining wall. We know that the geostatic stress at that point is going to be gamma Z2, and we know that Z2 is H, so it's going to be gamma what? H, right? Now the gamma here is the unit weight unit weight of soil mass So gamma prime naught is going to be, that is the sigma prime naught is going to be gamma what? H. And so if I want the at rest earth pressure, is going to be K naught gamma prime naught, and we know, sorry, sigma prime naught, sorry. And so my K naught is going to be gamma what? H. And so at this side is what? Gamma H K naught. Then at this side it was 0. So it's going to have this form of variation like a triangle. And so this is going to be the at rest So at a given depth, there's going to be a certain corresponding what um, at rest earth pressure acting. The maximum is going to be at the base, and the minimum is going to be at what? At the surface. Now, if we have these in place, if you have this in place, let me pan so that you can see what's down here a little bit. Mm. So if you have this at place, what then do we use it for? Now, there are two things that we need. We need two things. Two things. We need to know the force, the resultant force, P naught, the resultant force per unit width, per unit width of the retaining wall. We also need to know where this P naught will act from the base of the retaining wall, from the base of the retaining wall. So these are the two things that we will be looking for. So how do we find the resultant force per unit width with this distribution? You see, this distribution is along what the height of the retaining wall. So we want to accumulate all these stresses and make it one. Where will the resultant be? And what will be the resultant and where will it act? And so in this distribution, we can find the resultant by finding the area under this geometry. So just as we said, we need to find the P naught, which is the area under the distribution. Then we also need to find where it will act. So the area under this distribution is a triangle. So obviously it's going to be half the base, which is K naught gamma H, then the height, which is going to be times what? Height. So the P naught is going to be half K naught gamma H squared. Do you get it? Then where is going to act from the base? So assuming this is a resultant force. Where it's going to act at the base is what? 1/3 of the height. That is the centroid. Because this is a simple geometric figure, we can say that the centroid of the shape is where the resultant force will act. So if it is variation of at rest earth pressure when the soil has no water is this simple figure. Do you get it? Now, when there is water, that's what we will be looking at. When there is water, we are going to have several shapes. And so the total force or the resultant force is just going to be the sum of the individual areas. Now, the where the force is going to act from the base of the wall will not be easy. It's not going to be simply the centroid, but we have to do some calculation by taking moments and the rest. So yeah, we'll take an example on this question and we'll see how to go about. All right, so let's look at this question. So we have a 5 meter high retaining wall which is restrained from yielding, that is movement. So in this condition, we are looking at the at rest earth pressure because the retaining wall is not moving, and so the soil mass is at static equilibrium. So the backfill is cohesionless with this angle of friction 35 degrees, and the unit weight of the soil or the backfill is 18 kilonewton per meter. So we can represent this with a diagram. So let's say we have this to be our retaining wall, and the height is 5 meters. So let me change the color so that so we have a height of 5 meters. So from this side to this side is 5 meters. So this is my retaining wall. Forgive me with my diagram. Now, so meaning that the soil will start from here, the ground surface to the base. So this is the base of the soil. Then the unit weight of the soil is 18 kilonewton per meter squared. Then the angle of friction is 35 degrees, right? Okay. Now we are supposed to determine the at rest earth pressure per meter length of the wall. So in simple terms, we are supposed to find the variation from the top to the base. Do you get it? But the first thing that we need to do is to find our K naught. Now in this question, the only parameter given to us is our angle of what? Friction in the soil. And so this angle of friction, if you look at the three K naught formula that I gave you, we will use the Jackie because Jackie's formula can effectively use the angle of friction. So we can find our K naught, which is the first thing that we will do. So our K naught is going to be 1 minus sine 35, and that is what 0.426. Now let me put my diagram here and draw the variation. I think this is not nice. Let me erase. Let me draw my variation here. So let's say this is my retaining wall. So this will be at depth 0. This is at depth 5, right? So at at z equal to 0, right? As z is equal to 0, we are going to have our effective geostatic stress to be equal to gamma z, which is what? 0. And our at rest earth pressure is going to be A naught gamma z, and that is also going to be 0. So at the top of the retaining wall, we are going to have 0. Then at the base, so at z is equal to 5, our effective geostatic stress is going to be gamma z. Now, what is gamma? It is 18. What is z? 5. And so we are going to get what? 90 kilonewton per meter squared. Then what will be the at rest? That is the lateral force. At rest is equal to K naught gamma sigma prime naught. That is the geostatic stress. And so K naught, we know this to be what? Gamma Z. Now what was K naught? 0.426. And what was gamma Z? It was what? 90. And so our at rest earth pressure is going to be what? 95, sorry, 30. If you multiply this, so this is going to be 38.34 kilonewton per meter squared. So this is going to be the at rest pressure. So if I'm supposed to plot it here, we are going to have here is 0 and here is um the 38. So the 38.34, and I just join it with the straight line. So this is the variation of the forces. So from 0, then it gets to the base. Now, the next thing that we're supposed to do is to determine the resultant. So let's say it is B and this the A. The resultant, we said that the resultant force is equal to the area under the variation. So that is going to be half base times height. Now, what is the base? The base is 38.34, and what is the height? 5. And so the force there The force there is 95.85 kilonewton per meter. You get it? Then the point action of the resultant force, that is where the resultant force is going to act. So assuming if this is the resultant force, which is a 95.85, where it's going to act from the base is going to be 1/3 of its height. That's the centroid of the triangle. So 1/3 of its height, which is 5, is going to be what? It's going to be 1.67 meters. So the resultant force will act 1.67 meters from the base of the retaining wall, and we are done with it.